Hello and welcome back to Calculus 1 Exam 1 review. Yeah. So you won the test. Nothing I can do about that, right? The Exam 1 is going to cover chapters 1 and 2. Chapter 1, about 30% of the grade and problems, and chapter 2 about 70% of grade and problems. Chapter 1 is pre-calculus review. I already told you that you 100% the function definitions 100% on the test. If you don't know that, then the rest of the course is not possible for you, because I can sneak in a non-function and ask you to integrate, and then you write some stuff that, right? You need to spot immediately that an expression is not a function, which actually kills much of the calculus analysis that we are going to do. So you need to know that. So function definition. That's the statement, right? Function is a rule which assigns to x. You have all of that stuff. I am interested in graphing. Remember, there are no graphing calculators on the exam. I'm interested in graphing, which is your pre-calculus 1.6 section. You can search my YouTube for the full lecture, examples, and everything else. I will put PreCalc 1.6, so you know, if you go to tutoring center, they have the, I believe, 3 or 4 editions of the textbook. You can sit there and take a look at 1.6 in the pre-calculus textbook. They will allow you to have it for about 2 hours and so on. And then you can, you can take the book and then you can just, read, and then you can review and so on. So that's that. We also have important part on inverse function composition first. That's actually in 1.7 in PreCalc. The function composition is necessary. You've seen it in our continuity today, and you will also see a lot of that in derivatives, and so chapter 3, chapter 4, and then finally 5.5, the crown jewel of chapter 5, the use, substitution, and integration. All of them are based on function composition. So technically, if you don't learn function composition, you don't know function composition, about a third of the course, third of Calculus 1 will not be accessible to you at all. So you need to know that stuff. And then also the last part is the inverse. And that's 1.8 in a pre-calculus book, if you are interested to go and read. Also, you can find my pre-calculus 1.8 on the channel. So that's the chapter 1. I expect about, I would say, 3 problems. They might add to 28 points, 30 points, 32, 35 points, depending on whatever. Function definition is definitely going to be 4 points, or maybe 5, if I can. 4 points for 4 major words, and then maybe +1 for the actual everything else, right? The 5th point. Chapter 2. We are talking about limits, and you are expected to know all of the sections, right? 2.2 through 2.7. I told you 2.1 is the same as 3.1, and we'll take care of that when we get there. The 2.7, you have the precise definition of the derivative with epsilon delta, and you also have the those 2 graphs, one that shows graphically the approach when you have the limit, and the one that shows does not exist, right? So you need to know those. Explain in a paragraph how they graph works, if that's the question, something like that. But what do we have within limits? We are going to have so find the limit. And remember what I said. Plug in, all right? Graph, algebra, and finally chart. So plug in is 2.3, graph is 2.2, algebra is 2.3, and chart is 2.2. So those are all the ways to find the limit. Something will work. If nothing works other than a chart, so be it. It's going to be you punching the calculator, right, to get 6 values and then make, or 8 values or whatever, to find where the limit goes. We have definition for vertical asymptote, which is 2.4. Make sure that you know that the limit as x goes to c of f of x needs to, or plus or minus, right, from left to right, needs to be positive or negative infinity in order to have vertical asymptote. So this is the definition. This is what you learn, and you take this limit to show that there is asymptote. Be very careful what the question is asking for. The question might say, prove that f of x equal blah 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 has the vertical asymptote at 5. You see, I'm telling you it's a vertical asymptote of 5. So there's no reason for you to go and set denominator to 0 and perform any kind of witchcraft. All you need to do is to crank this limit with c goes to 5. If you get those infinities, yep, it's a vertical asymptote. If you're getting the finite value, nope, it's not a vertical asymptote. You have to write a sentence, it's not a vertical asymptote. It's open circle, no vertical asymptote because the limit is a finite number and so on. So your job is to do limits, not to set denominator to 0 and say, yep, it's 5 and walk away because I told you it's 5 in the text. So to find vertical asymptote, you have to crank the limit. This is calculus 1. Same story goes for definition for horizontal asymptote, 2.5, limits at infinity, and you have the limit x goes to positive or negative infinity, f of x, and you are looking for either L for horizontal asymptote or plus minus infinity and behavior. You remember that we had some of those interesting problems when in 2.5. So when we divide by the highest exponent, right? So that should be on the test as well. So now methods of computing. 2.5 limits. All right, think about that. 2.6 continuity. So now all definitions plus theorems. Purple theorem, red theorem number 1, red theorem number 2. So what do you have? You have the point continuity, global continuity. You have global continuity for functions. You have combinations of functions. So all of those are necessary. There could be a statement, right? Question might say, list all the functions, which you learned, right? List all the functions that are globally continuous, in which case you write polynomial, sine, cosine, ln, e to the x, ln x, square root of x, absolute value of x, right? You write those down. So know all of those definitions, and then compute 3 rules. And I think that's it. Show f of x is globally continuous using, I'm just going to point the arrow, the theorems, right? So we did that problem with e to the x divided by x squared, and I showed you those calculus 2 problems that I did. Right, so that kind of, you write a paragraph or something. Maybe I should write show, I'll put here paragraph. You know what that means. And finally 2.7, precise limit definition. So statement and 2 graphs, L and D and E. So this is the outline for the entire exam. It clearly spells out expectations. So chapter 1, function definition statement as given. Graphing. For graphing, you might look into, let me clarify graphing. Now if you are able to do stuff like this, x plus 5, y equals e to the x minus 1, y equals 4 sine x. So the basic stuff. So this one is shifted much better. Negative 5, 5 units to the left. This one is shifted 1 unit to the right, so it goes like this. This is 1, 1. And 4 sine. So it's going to look like this if the regular sine was like that, right? 4 times stretched, 4 times vertically. So this is the type of graph. So you are looking at the basic graph. Guys, I gave you the list of things that you are responsible for. You are in calculus class now. No graphing calculators on the exam. So your first lecture has the list of all the graphs. They will be just shifted or multiplied by a number. You're not going to see, you know, crazy graphs, which we are going to learn in chapter 4. Then, right? Why have chapter 4? So you are going to learn how to graph by hand, you know, x times ln squared x. You will know how to do that by hand when you do, when you learn concepts in chapter 4. Now, in chapters 1, as a review, chapter 2, you need to know how to graph basic functions that are shifted, reflected, you know, so simple manipulations of those graphs. Exam should have 10 questions, something like that. It's designed to be about an hour, 20 minutes long. You finish early, obviously you will check your work, double check your work. No notes, no formula sheet, no graphing calculator. You can bring scientific calculator. That's the one. You can model it for everyone. Perfect. That's it. So that's a scientific calculator. Make sure that you pay attention which scientific calculator you pick up, because there are scientific calculators that do not have trig on them, because those are business-related calculators and they don't need trig. So there are some scientific calculators, they would look the same, except they have no sine, cosine buttons, so you will not be able to compute certain things. So make sure that your scientific calculator has these things. This is the one that does have it. So TI 30. Now you can borrow the calculator from the tutoring center. You bring the ID with your current face on it, and then the firstborn child or something, and you get the calculator. What else? You can also bring the basic solar calculator if you know all the other values, it's fine. Or you can show up with no calculator, that's okay as well. I mean, that's the idea for your schools now, to push for no calculator at all. Then you won't have the issues of this kind, right? Where the order of operations that you have the idea of and the calculator are not synced, and then, right? This was operator issue, right? Like, I'm not sure which one of you guys, but it doesn't matter. I noticed on the larger scale, the more you rely on the calculator, the more error and mistakes pop up, because you tend to think less because you have the security blanket, and then, right? So mistakes like that happen. This was the honest mistake, but still the answer was wrong. So you have to be careful about those kind of things. Partial credit is going to be issued when the result is not correct, but you provided steps and you did work and you gave it an honest shot, as you would say. If you have, let's say, problem number 3 and the whole thing is empty and just number 18, which is wrong, well, there are no basis for partial credit there. There are no extra credit questions. There are no retakes on redos or makeup or anything like that. You pick the date, and you pick the date to be next week, which means that your extra quizzes that you can use to study and prepare for the exam will open starting tomorrow, 6 a.m. So Sunday would be the first quiz, 6 a.m. Closes at midnight that day, minute before midnight. The next quiz will open on Monday, 6 a.m. and then Tuesday and then Thursday. They will close every day. You will have 7 quizzes. The 7th quiz, since this is a morning class, will open on Friday along with 6. So Friday is the day when you can solve 2 quizzes. Or you can get up at 6 and solve the quiz before you come to class. And if you don't do well, then you can solve it after the exam at some point during the day, because the last quiz will close. If our class ends at whatever, 2 o'clock or whatever, it will close 10 hours later. So you still have time after the exam to complete the last quiz if you haven't had chance in the morning. I tend to open the last quiz, I said tend to open the day before along with the 6th quiz, because you are an early class. If your class was 5 p.m., I wouldn't bother, because it's better to do all of the quizzes before the test, obviously, than to do the last quiz after. It's just common sense. And I think that's it. Do you guys have any? Yes?
For the next class, what were we responsible for exactly? So you have the quizzes. What kind of class prep? Because I remember the syllabus isn't quite synced up to what we're up to right now.
Well, we are going to cover 3.1 and 3.2 after exam.
Okay, so we should have class prep.
3.1, 3.2. If you hand in any of those or all of those, then you don't have any class preps to work on for the next class. Generally try to, whenever we end in class, you are guaranteed to see next 3 sections, or maybe even 4, the next class, possibly 4, if we don't have exam or something like that. So you should always bring minimum of next 3 sections. Now we have exam that's going to take, with distribution and collecting it and everything else, at least hour and a half. So I don't think I will be able to teach 3 sections afterwards, right? So we'll start with the exam at about 8:40, and then when we end the exam at 10 or so, 10, I don't know, we'll have the break, short break, and then immediately 3-1, and then break, and then 3-2. Yes?
The class preps we did for like the earlier stuff, we didn't get those back, so we can use them to
The
study.
issue is that I didn't have the final rosters. Those final rosters were given to us, and I started plugging stuff in. So unfortunately, you're gonna miss it for this exam unless you somehow get it from me. But once I catch up, then I can actually, while you guys do the lab or something, I can plug in whatever's on the desk and return it the same day, not even wait a week. It's always issue in the first 2 weeks. I always have that issue because the school allows for instructor shopping or whatever it is, and we don't have a final rosters for me to create the grade book for all of this stuff. So that's why. So I have piles that big now already. Other questions, concerns? Yes?
For the second graph, exponential x minus 1, I'm not convinced with it. Can you explain it to me?
Sure. So when we have graphing, we have f of x plus minus c, which is the shift up, down, and we have f of x plus minus c, which is the shift left, right. Our graph that I proposed earlier was y equals e to the x minus 1. You see that the modification is given directly to x, which follows under this rule, rather than being e to the x minus 1, which would follow here. So it's very important whether this right is like that, or if the -1 is on the bottom. Now these two, if you draw them sufficiently small, it's clear that both of them are in the exponent. And then it's clear that belongs to this situation. The negative side is the left. The positive is the left shift, and the negative is the shift to the right. So the original function for e to the x would be the function that goes through 1. And the function that we need to graph needs to move 1 unit to the right, and will keep the same shape. It's just that it's going to go through 1 unit to the right. Oh yeah, this is negative. Yeah, you're right. This is negative x. So it will look like this. So this one is e to the x, and this one is e to the x minus 1. Which actually reminds me of that evil situation. Let's take a look at log base 3 of negative x plus 2. Is this shift to the left or shift to the right? So now, if you recall, you have to factor this negative sign. Because the x plus 2 needs to be 1 unit, and the negative sign is a reflection. Reflection needs to be applied to the group. You can't have this situation. It's okay to have negative x, but it's not considered as negative x for graphing. It's considered as x, and then the negative is the reflection on the one of the axes, depending where the minus is. So in this case now, this is reflection on y-axis, and you see that this one is right too. But over here it looks like it's 2 to the left. So it's very important to catch that thing. And this is what I was thinking when I was writing the problem. So the graph of what I wanted stayed in my head, but I decided not to write that problem, and then I put the wrong graph. I'll explain that with e to the x as well. So the original log looks like this. This is just log base 3, or any base, of x. It's not humanly possible to do perfect job on graphing logs. So they're all going to look like this, going through 1. And now I need to shift 2 units to the right. That means that the vertical asymptote that used to be on the y-axis is now here. And we also have the reflection. Now this reflection is on what axis? X or y? Y-axis. So you should do reflection first and then shift stuff. So when you reflect this, right, it would reflect, maybe draw another graph. I'm going to erase this asymptote. So first I'm going to reflect the function. When I reflect on the y-axis, I'm going to get this. Going through -1. So this one is log base 3 of -x. And now I have the +2, which will give me the shift, and that's going to be the final version of the graph. So our old graph goes to this point. We need to move everything to the right. So I told you already that the vertical asymptote is going to be at 2. And the function is going to go through +1. Like this. And this is our finite stage. So this is the log base 3 of negative x plus 2. 1 and y, and we're good to go. Yes?
You have all the chapters and lines in PDF files, like so it's the same way from last year?
Yes.
Okay.
Under notes. The problem that I originally wanted to put here was e to the negative x plus 1. This will work the same way. You are going to write this as e to the negative x minus 1. So you draw default function e to the x, and then you reflect e to the negative x, and then you shift 1 unit to the right. This is the graph that I was thinking of, but I decided to change the function. There we go. So that's the basics of graphing. 1 over x squared, like 1 over x squared minus 1 over, not 1 over x squared minus 1. 1 over x minus 1, everything squared, stuff like that. So just shift to the right. Other questions, concerns? Yes?
You've got like 2 deflections, one on the y-axis and one on the x. Like on the previous, it could be negative and so
Okay.
which word would you prefer to use?
It doesn't matter. It's important to do reflections first, period. So whatever reflection you want to do first, if both are present, is fine. Just make sure you don't shift function prior to that. because shifting the function might make the problem harder to do. You see, over here, when you look at this problem, if you move the asymptote first, right, the function would go to this point. And then what I've seen is students say, oh, and then it's a reflection on the y-axis, and then draw all the way up there what it should be here, right? Because the asymptote becomes your new y-axis, and you shift on the asymptote, you don't shift on the y. So that's why if you have the reflections, just shift them before you move anything, and you don't have to worry about those issues. Graphing piecewise functions, right? You have a piece between 0 and 2, and piece between 2 and 4, and piece from 4 to infinity. So graphing piecewise functions, graphing absolute value of, can you quickly graph absolute cosine x in your notes? Stuff like that, right? Because we need that. We need that along the way. So, what it looks like.
The hills behind the Mario level?
Yes. So, if you draw the cosine, you know it does this, right? And then you take each one of these negative, and bump it up. And then you take eraser, and you erase the negatives. And that takes care of the inverse cosine graph. Not inverse cosine, sorry, absolute value cosine. So this is where the 2 pi is. And this is where the negative 2 pi is. Nice. For limits, you know that you are supposed to try to plug in. If you don't get the value, you will immediately see if you can graph. If you can't graph, hope for algebra. And if that doesn't pan out, calculator, and punch numbers. Any other questions, concerns, problems, concepts, anything? Going once, going twice, and so, all right. If you have any individual questions, so you can talk to me, obviously, but we're going to start the lab portion, so 2-3 minutes break, and the rest is the lab.